So we've talked about this in terms of these Pople basis sets, but there are other types of basis sets. For example, one very popular one is what's known as the correlation consistent basis sets. I've used these in the little bit of computational chemistry that I've done. And these are basis sets that are designed to work well for things beyond Hartree-Fock that are dealing with electron correlation. And so the notation for these look something like OG CC. Let me make sure I get my things in order. Yeah, okay, OG PVDZ basis set. And these are still related to the ideas that we've talked about with the Pople basis sets. The actual mathematical functions are a little bit different. This still involves Gaussians. I'm not sure, exactly what the difference is. So the CC here stands for correlation consistent. The P here indicates that there are polarization functions present. So that's the same as the stars in our Pople type basis set. V here means that this is for valence electrons. DZ stands for double zeta. So it's all the same ideas, just the notation's a little bit different. And AUG here, it means augmented, and this is diffuse functions. So this is the same, similar idea as the pluses from the Pople type basis set. And so a lot of these basis sets still have the same ideas as each other. It's just the specific details are a little bit different from basis set to basis set, and they may work better for particular problems versus other problems. And so there's a whole smorgasbord of these, right? So we've just looked at a couple of some of the more common basis sets that are used in computational chemistry, but there's a lot more to it than this. If this is interesting to you, there's lots of research that you can do, and there are people who develop new basis sets and develop new methods, and that's what their research is. And they spend all their time writing code, and they enjoy it. And so in our final video for this chapter, we're just going to look at an example of how we would go about doing a calculation, what the results might look like, using an online website called ChemCompute that lets us use one of these computational chemistry packages. But the nice thing is that you can do it from the comfort of your own home. So there's a powerful computer somewhere else that's doing the actual calculation. And we also have access at Con in Mark's computer labs to a program called Gaussian that implements a lot of these methods and basis sets that we've talked about in this class. And so we can also do this here on campus. I'm not currently on campus, so which is why I'm not doing it there. But there are lots of different programs that allow us to do these sorts of calculations.